Oh, good. Okay.
All right, welcome everybody. We're so glad to have you here today. We have a special session with Michalis Kamburelis. Many of you know Michalis. He is a longtime contributor to X3D graphics, to Vermal. He's the developer of the Castle game engine, which is open source built on Pascal programming language. It has many, many capabilities, many, many spin-off applications. And he's also the architect of how X3D has been able to, has adopted the glTF 2.0 standard as our rendering. We can inline it, we can draw render shapes with the exact same excellent high fidelity, high resolution, physically based rendering. Okay, so something old, something new today. Michalis is going to brief us on the skin node that he's suggesting. It's a really interesting technical point because it captures how glTF does human animation, but it does it a bit differently from our human animation. So we want to make sure that we understand it well, and then we could figure out, okay, how do we use this? Is it especially, or is it something that goes central, or more work, or what? So welcome everyone to the frontier, the cutting edge. This is where the future gets invented. Michalis, please make us smarter today.
Okay, thank you. I'm very humbled. That was a really great introduction. Thank you very much. Okay, so I guess I will share the screen and I will keep talking. Just make sure, yeah, as Don said before recording, like interrupt me if anything is unclear, and also interrupt me if like my voice is unclear or if I start talking too fast because yeah, I tend to get excited when talking about things like graphical stuff, and then I sometimes talk like a crazy person, too fast, too fast. So like, stop me before it gets there. Okay, so you should see my screen sharing, right? This is just my desktop. Yeah. If somebody can confirm that you can see my desktop, I will appreciate.
I can see it.
Thank you, thank you. No, yeah. So I'm doing a few things, as like Don has nicely said. Like I'm doing basically, I'm the project lead of Castle Game Engine, and this kind of involves a few things. Yes, so we have this game engine where you can kind of create new games, and the central thing of how you create a game is something called T-Castle Scene. And the T-Castle Scene, like the soldier here, well, it can be loaded from a number of models. Yeah, so underneath the T-Castle Scene, you can have a glTF model, you can have an XVD model, and you can have actually we support like 14, I think, formats of three-dimensional models. Yeah, so this is like my, you can say, genesis, my reason essentially for being here, being involved in X3D and glTF and everything else essentially. Yeah? My reason for being involved in all of this is that I actually need it. And in the sense, I want to be able to create 3D models in professional applications like Blender, Maya, 3D Studio. I count those three as like most popular ones from my knowledge. And then, yeah, I want to be able to use all those formats to basically express fun stuff using custom game engine and render it for games and non-games for everything else. Yeah. And as like Don mentioned, we have a number of, you can call them spin-off applications from the engine. So we have this model viewer, which I guess is most known application of custom game engine in this crowd. Yeah, so you probably mostly know me from Castle Game Engine. From Castle Model Viewer. Yeah, so this is a desktop application to view three-dimensional models in all of those formats that I mentioned, in particular glTF and X3D. Yeah? And the custom model viewer, it also has a mobile version. We have the Android iOS version. We also have a model converter, which can be used from the command line. We also have this converter in a version that can be used from the web. And we also actually are working on a web version of this model viewer. So something similar to XFreedom and Excite that run in browser from the start because they've been developed using JavaScript. In case of Castle Game Engine, we are developed using Pascal, but we can compile our engine to do something called WebAssembly, which is basically something that runs in your browser without any plugin or anything else. Yeah. So this is an example of, this one is actually a glTF model running in a browser, but I can switch here for, it's actually a mix of glTF and X3D model. In this case, this is also a mix of glTF and X3D models actually, and I have here some more three-dimensional models. Yeah, I want to make it basically more flexible so that you could load here any model you want to. And that's what we're doing, yeah. So we're doing a bunch of things around Castle Game Engine, around XVD and glTF, yeah. As Don also, I think, mentioned or suggested, well, one way how you can combine X3D and glTF is that you can use the inline node in X3D to kind of insert glTF inside X3D, yeah. Let me just open some very simple example of it. Let me just move this zoom. So I want to move like the zoom thing so that it doesn't bother me. Okay. So like this is an example of an X3D file. And this X3D file is just using the inline node in X3D to insert the glTF, in this case with the GLB extension, to insert glTF file as a part inside the glTF file. Yeah? And this is actually a bit relevant example because it's also showing the skin animation. So let me actually run it. It's called skin anim run animations from X3D. Yeah? So when I open it in our custom model viewer, what happens is you actually see models defined in two formats, but they are kind of connected seamlessly, you can call it, yeah? So one part is the skinned anim GLB. So this is it. And I'm sorry it looks ugly. This is the model I made, like literally me. I'm a developer, yeah? I'm not an artist. I'm sorry it looks ugly, yeah? You can make pretty things, but not me, yeah? Let somebody else make pretty things. I can make silly things. I can make ugly things. Yeah. So this is a very silly model using skinned animation in glTF. It was created in Blender, and I exported it to the GLB file. And then this is an XVD model. This XVD model is using inline to display this glTF model. And then we, from the glTF, we're exporting some nodes. Kind of works like an export clause in XVD. And then in XVD format, we can add some additional things on top of it. For example, we can define a navigation. Yeah, so do I have a headlight or not? Do I have specific navigation properties? I can define some helpful text. I can define some touch sensors. And I can connect those touch sensors using XVD roots. So I can say that if you click on this touch sensor, then you should run this animation, jump. And if you click on another touch sensor, then you run another animation, walk, okay? And this animation, walk and jump, they are defined in glTF file. From the XVD perspective, they are time sensors. From the glTF perspective, they are animations. It's really completely the same underneath in our engine. That's why I don't care in the sense it's really the same thing. For the custom game engine, it's a time sensor called jump. But we get this time sensor when we read glTF file, and that's okay. Yeah? And it actually works. Yeah. So if I click here, yeah, touch sensor works to run this or that animation. Okay. So that's basically a short overview, maybe already longer than necessary, of what I'm doing and where I'm coming from. Thank you. Thank you. Okay. Yeah. So now I wanted to talk specifically about the skin node, which is kind of a new addition. We actually have worked on it for a few months, so it took some time to finalize, to be honest. And there were some details that I wanted to make essentially perfect. So we kind of have announced it, and now I want to tell you what it is about, because I do understand that some of those things, there is something like duplication of what I'm doing with some other work, like HAnim that Don mentioned, and I want to make it clear, like basically why I did it, And I'm not really trying to propose here anything. I'm just telling you what I've done and why, yeah? And then we can talk about maybe is how is this useful for other people, or maybe not. Maybe it's something very specific from Nicholas. Maybe it's something very specifically just useful for our engine. I'm fine either way, yeah, basically. What I'm trying, I guess, to say is, first of all, forgive me because I'm getting too talkative already. I may be too tired. Second of all, approach what I'm saying with an open mind. I'm not trying to push here anything that it has to be in the specification or whatever. I'm just telling you what I've done and why it makes sense for me. Okay. And that's it. Yeah. And have patience with me because as you can see, I already get like too talkative. Okay. So the idea is that, well, okay, so what is the skinned animation basically? Yeah, something that maybe should be set as an introduction here. I mean, I think everybody actually in this call know it, but just for the sake of, I guess, demonstration purpose, yes, for the video. So let me just show very quickly what is a skinned animation using, of course, Blender. Yeah. So if I go into Blender, I can, let's say that I want to subdivide this thing, and let's say that I'm going to make, on this video call, I'm going to make an amazing humanoid, okay? So I'm going to make a humanoid with hands and one leg, okay? That's all that we have time for. Okay, I'm not two. No, I only make two legs, okay? I'm like really, really good, yeah? And as you can see, I'm a developer, okay? So this is how I make human in Blender. I'm sure other people can do it better, yeah? But the point of the skinned animation is that, okay, now I have a mesh that is ugly in this case, but in general, a real artist can make something pretty here. So imagine that this is something pretty. And then on this mesh, a mesh is in my, when I say mesh, I mean a set of vertices connected with polygons, faces. Some software calls it mesh. We call it indexed face set or indexed triangle set in X3D. glTF actually calls it also mesh, actually mesh with primitives. Yeah, so all those things mean really the same thing. Yeah, so this is a mesh. Okay, so yeah, I mean, like, okay, how do I animate it easily? Yeah, in this case, it's a simple mesh, but imagine that a real human, if you would like to model it, it could be a really complicated mesh with a lot of vertices. Okay, so what you do in Blender is you add something called armature, which is more commonly actually called skin. Sorry, skeleton, yeah? And when you add it, yeah, so the armature is actually composed from what is called bones in Blender, but what is more commonly called joints in both glTF and X3D, okay? So what you see here, this yellow or green, I should admit I'm colorblind at this point, so I'm not sure if it's yellow or green, and I honestly don't remember. But I think the armature, I think it's green, this thing in the middle, it represents a bone in Blender terminology, or a joint in the terminology of most of the other applications. So the idea is that this is something not visible, a bit like in a human body, okay? You don't see your bones, but it's driving the skin. It's inside the skin, and by moving the bone, you're actually moving the skin. Let me see, can I make something really silly, really quick, okay? Just to demonstrate that, well, it works basically. I will give up quickly to be clear if I see that I cannot make it quickly, and I can see already that my computer is not cooperating right now. So okay, let me do something really silly in this way, okay? So here I make a bone that is actually a child of a different bone, and let me make a different bone for a different arm, okay? Yeah, I think it's actually good enough for the demo, yeah? So let's suppose that this is a bone inside my spine, and this is my arm, and this is my forearm, yeah? So like this ending of my hand, yeah? If I would like to make really a hand, I would make here more fingers, yeah? So I guess things like this, and now I have a hand that has 3 fingers, okay? And I should stop already. This is getting more detailed than I intended, yeah? Now, the idea is that you make a process that involves connecting this skin, which is a mesh, connecting the mesh, sorry, to your skeleton, because you want to drive the mesh with your bones, okay? So in Blender, what I do is I select the mesh, and then I shift select the armature, and then I say set parent to armature with, and let's say that with automatic weights as something sensible, yeah? And what does it mean? Is it means that I have a joint now. I have a joint which is a bone in my skeleton, and now I can move this joint. And when I move this joint, I'm actually not only moving the joint, but I'm also moving the mesh underneath. Yeah, and you can see it here. When I'm moving this thing, I mean, it's actually better demonstration than I anticipated. Yeah, when I'm moving this thing of my hand, I'm actually moving also this silly box that represents my hand. And here, if I move the arm, okay, I'm moving the arm, and it's actually moving this piece of the mesh. And of course, it's also moving the forearm, so also this thing moves. Yeah? So it kind of behaves like, well, reasonable or not, okay? We've made it in 1 minute human. And so this is what I guess everybody here knows. So this was, I guess, just some recap of something that we all know. To be clear, this this skeleton, yeah, this skeleton, this collection of joints is not something that is going to be visible by the actual user of your application. Okay, Blender displays it just for us as an artist, as a person who's doing it, but the actual user is only going to see this, yeah, just the final mesh that has been deformed by manipulating the joints. Okay, and now what we're going for is we want to display it in Castle Game Engine or everywhere else. Okay, so ideally we have this magic button that says export to glTF, export to X3D, and they all should ideally just work perfectly and allow us to open the resulting animation in Castle Game Engine and any other application that can support the X3D and glTF model formats. And yeah, we're going now to things that are, I guess, not basic, but maybe more interesting for most people on this call. So how do I this? I mean, how in general can we do it in X3D? Well, X3D has really outside of this skin now that I'm now going to talk about, but so far the standard way in X3D to manipulate the skin is the H-anim, which is a bit of a it's not a completely separate specification, but it is, I mean, it is closely tied, and everybody here on this call know this, that is an application developed closely together with the X3D standard. But like, there is an X3D standard specification, and it kind of links. It says that you can use H-anim nodes following the H-anim specification, and the H-anim nodes, they define you. Well, the idea of the H-anim specification, I'm sorry here, I will probably oversimplify things that you all here have been working for years, okay? But if I will simplify it from my side, it's a way to specify humans, but also actually other creatures, and allow to animate them in a realistic way. And the H-anim kind of defines various ways how you can define those animations and how you can attach things to the points of your creatures, like to your hands, and put a hat on your head, and so on. And the H-anim gives us a number of ways here how we can actually animate those creatures. And in particular, one of those ways is the skinned animation concept. Okay, it's described if I go to the humanoid, there's a super important field skin in the H-anim humanoid node. That's how it's called in the X3D. And this allows us to attach a skin, which is just a mesh. It's actually nicely said here that this is a mesh. So this is a mesh that is going to be manipulated by the skeleton composed of joints. So if I would like to convert this Blender that I silly thing that I made in Blender a minute ago into H-anim following X3D standard, I would convert it into a humanoid node. I would use the skin to express the mesh, and I would use the joints to express, the joints is actually a list. I would use the skeleton to express the hierarchy of my joints. And there's a lot of course, other useful information here. One of the most information here is like the weights, because I want to know for each joint which vertexes should it manipulate and with what strength, okay? And this in turn, in case of animation, is supported by using the anim joint node, which has something called skin chord weights and indexes. And this is telling us which vertices of the mesh are affected by this joint and with what weights. So far, I've not been telling anything about the skin node. I know. I just wanted to kind of lay the ground for what I'm going to talk about, which is the skin node. Because I am proposed basically a different way of expressing a skinned animation in X3D. And that's why it's so important that I kind of explain to you why I'm even doing this thing, why I'm doing something a little bit different, yeah, instead of just following the H-anim standard for everything. Yeah? So I'm going to explain it. Yeah. So the idea is that the skin node allows us to express, well, actually also the same thing that I've shown in Blender, in a lot of ways, in a similar ways. So if you would express, instead of the humanoid node in the H-anim node, in the H-anim specification, in our case, you would use the skin node as like the top level container of your character, or really any other creature that you want to animate. Then you have a number of shapes that can be deformed by the skinned animation. And this is already a bit similar, a bit different than what the H-anim specification is proposing, because effectively in the H-anim specification, if you look here, you have skin coordinates. Yeah? So like the skin can be a sequence of objects, yeah, but you have only the skin coordinates. They have to be one set of coordinates and one set of normals, yeah. In case of the X3D specification, this is a sequence. This links to the coordinate node, if I'm not mistaken. Yeah. So you effectively, yes.
Sorry, sorry, Michalis.
Okay. Yeah. Go ahead and interrupt me if I say something.
No, something else.
Yeah,
Okay.
Michalis, the answer to your question was yes. Please continue.
Thank you very much. Thank you very much. I didn't hear. Thank you then very much. Yes, I needed that. Yes, thank you. So in case of our skin node, we are going to be a bit more flexible in that you can actually have multiple meshes here with multiple completely independent coordinate nodes, and they can all be animated using one skin. Okay, so this is already a bit different than the H-anim specification of the humanoid. Then we have something called skeleton, which describes the hierarchy of joints. Again, similar and different to the H-anim, right? Because H-anim also has the skeleton field, and it also actually serves the same purpose in the H-anim. The skeleton describes the hierarchy of joints. This is exactly the same thing in our case, except and here I wanted actually to do something simpler, because I thought that maybe I can just use the regular transform node from the X3D specification that we all already kind of know and love. Maybe I can just use this regular transformation node to express the joints in the skinned animation. Why did I decide to do that? Because actually that's also what the glTF is doing. If you look at the glTF standard, they have their model is obviously their model is a set of transformations, a hierarchy of transformation. That's how we all are doing 3D models right now. And in their case, they said that, okay, like we have those joints, but the joints are nothing special. They said the joints are just transformations, just like any other transformation. You can just say that some of the transformations, they perform the role of joints, but they are still just regular transformations. Yeah? So I kind of wanted to see, can I achieve the same simplicity? So in our case, the skeleton of the skin node, it's a hierarchy of joints, yeah, but you don't see here joints. You just see here the transform nodes. Then we have also a list of joints, which is very similar to what the H-anim humanoid also has a list of joints that was made optional by the latest revisions. In case of the skin node, it's still obligatory. And let me explain now why, okay? Because what I have shown here is, okay, so we have a hierarchy of joints and we have some meshes. Well, how do they kind of connect to each other? Yeah, because something that I kind of didn't show you when I was showing you this Blender stuff, but is actually critical. Yeah, is that for each of those bones or joints, whichever name you prefer, doesn't matter. So for each of those bones or joints, you actually have like a set of vertices that are affected by this bone. I can actually even show how would you modify it in Blender. So in Blender, you would go to weight painting and you can select a particular bone that you could do in a smarter way. But now I will just do it in a kind of a silly way, okay? So here I can select a bone, and as you can see, it would help if I would give reasonable names for my bones. Instead, they are called bone 002. Yeah. So the colors that you see here tell me for the bone 002 which vertices are going to be affected when I move or rotate or even scale if I'm crazy, or even scale my bone 002. So which vertices and with what strength are going to be affected. Blue here means nothing, so 0. Red here means 1, so maximally affected with what I'm doing, yeah? And I can, of course, the point in Blender is that I can change it, yeah? So, for example, I can make this bone, for example, affect also other vertices, which doesn't really make sense in this silly example, yeah? But just to show you that I can. So, for each bone or for each joint, I'm now going to use both of those words all the time, yeah? So for each joint, you want to know which vertices are affected and with what strength is each vertex being affected. The way this is specified in the HANIM specification, I already briefly showed, is that for each joint, you have exactly a list telling you this, okay? Now, in case of the skin node, it's a bit different. In case of the skin node, we move this information inside the geometry node. So indexed face set node and a bunch of other nodes, geometry nodes, the indexed triangle set, and so on, they get two new fields. One is called skin weights 0, and the other is called skin joint 0. How does it work? If you look at the indexed face set, you have coordinates and how they connect into a polygon, obviously. And now for each of the vertices, we say that we want to know, at least in this field, we only want to know the four most important joints that affect this vertex. So here we see the first 4 number in the list of skin joint 0, and those first 4 number, they correspond to the first vertex, okay? So what this means is that the first vertex is affected by joints 0, 1, and those actually are not necessary because their weights are 0, okay? So to make sense of it, you also look at the skin weights 0 field, also at the first 4 fields of it. And here we can see the weights. So half, 0, 0. Okay, so the first vertex, this one, is affected by the joint 0 with strength half, and it's affected by joint 1 with strength again half. And the rest of this vector doesn't matter because the weights are 0, okay? So it's a bit of like, you can say it's a transformed way of what the HANIM is exposing, of what the Blender is also exposing here. We kind of transform it into a bit of a different way. Why is this useful? Because this is kind of straightforward to pass to the shaders, actually. So let's get to it, okay? So I'm going to like get to how it looks like in a second. Let me just first see, can I have something more interesting here to say? Yes, one thing I wanted to mention here is that by moving this information about skin joints and skin weights, by moving this information into the geometry node, this is how we actually achieved that we can have multiple shapes with independent geometry, all affected by one skin, okay? Because now this information is inside the geometry nodes. So if you have 10 geometry nodes affected by one skeleton, no problem. Yeah, you can now do this And this is a bit different than in case of the HAnim standard, where you can have, well, inside the skin, you can have 10 meshes. Yes, but then you only can have one skin cord, yeah? Which is a limitation that we wanted to overcome. Okay, so this was kind of an introduction how the skin node looks like in X3D. Now, why? I still didn't tell you why. Yeah? I'm just telling you, oh, I made this different thing, and it's a bit different, a bit similar to HAnim. Yeah, that's a short summary of what I said so far. Wait, why did I even do this? Yeah, so I was looking at the glTF. As Don mentioned, we have kind of designed the physical material in X3D version 4. And the nice property of the physical material in XVD is that it's very, very consistent with what glTF is doing, which means that a lot of essentially, you can call them hard decisions, have been already made for us in a way that I think good, like Kronos has done a good job there. And we can kind of just use this, basically, those decisions, and we can kind of use this knowledge how to convert Blender physical materials. We can use this knowledge now to also do the similar thing in X3D, while also preserving the X3D strengths. Yeah, so like the physical material in X3D, it's still actually consistent with the rest of X3D. So while doing it, we have also extended X3D Phong material, and I do believe that like the physical material in X3D is a nice addition that, you know, even if you don't know glTF, the physical material basically stands on its own, yeah, and allows us to do this nice realistic rendering. So with the skin node, I was kind of wondering, can I achieve the same thing? And why is this? And now, why was this actually so much tempting for me to try a different approach than glTF? Well, one thing is that the implementation of the glTF skinned animation is super simple to explain. I will dare to say it. And it's also very short. What I'm opening for you right now is actually a glTF reference material, document linked from this skinned animation description. And if you look there, you can actually see that the skinned animation, it kind of starts here, and then this is it. So this is 1.5 pages, and they describe how to make the skinned animation. Not only how it's specified in the glTF file, it also actually gives you an implementation of it, yeah? This is a shader in the OpenGL shading language that actually performs the skinned animation. Now, I am amazed by this simplicity. Admittedly, yeah? I am amazed by the simplicity how the glTF did define the skinned animation, and that was kind of my way of thinking that, okay, I want to be able to implement skinned animation in Castle Game Engine with the same simplicity and also with the same efficiency, because if the shaders on GPU are going to perform it, and like this is as simple as you can get, essentially. This is as simple shader code as you can get. If I can make skinned animation perform using this code, then we're going to have something that is simple to implement and also very efficient to use. So that's why I wanted to make it, yeah? So I do think that this approach like lends itself nicely to basically an extremely efficient implementation. So that's one rationale for doing it. Another rationale for doing it is that, well, it matches glTF, obviously. And in case when our engine wants to support both glTF and X3D and some other formats, well, it actually makes sense that when we read something from glTF, we don't do some complex. We don't do some complex transformation of it, for example, to HAnim. Instead, I wanted to avoid it. I was thinking like, I mean, it's possible, to be clear. I do believe I'm sure it's possible to convert glTF skinned animation to HAnim animation, but it involves doing some complex things. I thought like, how about I don't do them? How about instead I do a very simple transformation of the glTF information into a skin node, and then I do a very simple implementation of the skin node, kind of following what glTF is doing. And like for me, it's kind of a win-win. I mean, okay, not 100%, yeah, but I win in two things, yeah, simplicity reading glTF is simple. It's trivial to read glTF into such node of X3Ds called skin. And then I win simplicity and efficiency when it comes to rendering, because I can just load this information into GPU. And actually, let me prove to you that it remained a simple skin animation. The vertex shader. Oh, give me a second. I believe it's skin ani. Okay. So what you saw before was the pseudocode of the shader. This is the actual shader code performing the skin animation. Yeah. So you can say that, I got my dream in a way, yeah. Except for workarounding some case for the old Blender bug, this real implementation that really works looks almost the same as this sample implementation in this one page of PDF, yeah. So this is terribly simple implementation, and it is terribly efficient, I would dare so, because this is just done by GPU on shaders. So doing it on every vertex, it's really fast, basically. Yeah. So why I've done it? Yeah. So I started now saying why. Yeah. So it's transforming this from glTF to skin node is straightforward. Implementing this is very efficient because we can just do it using shaders. And you have a bunch of resources about it, of course. So you can have all the glTF resources about how to render glTF efficiently. Now they also apply here. Now they also apply to this skin node. Some minor things that I wanted to achieve is also I wanted to, because I know that HANIM specification does a lot of, well, great things, yeah? Things like, for example, specify the standards for the joint names of a human, yeah? And to be clear, like, this is very valuable. There are other standards that attempt to do this, like VRM and so on, but I think like HANIM does a great job here. But like, essentially, in some use cases, like for a game engine that as you saw I'm doing, those use cases, those parts of the HANIM, well, I didn't need them. It's as simple as that. That's why I said that, like, have an open mind. Yeah, I'm not trying to tell you that the skin node is an answer to the universe and everything. I'm just telling you why I've done it. Yeah. So in our case, in case of a game engine, we don't need some parts of the HANIM, like the standardization of the joint names. And if somebody needs them, then they can just follow the HANIM standards for the joint names. Yeah. Go ahead. Basically, I don't try to reinvent it. It's too difficult for me. It's you guys can do it. You guys and girls can do it. Yeah, I don't want to duplicate this job. Yeah. What I wanted to achieve is I wanted to have a bit of simplicity. Like I wanted to use transform nodes in case of HIM joint because I kind of thought that, well, let's try. Yeah. I mean, transform node is kind of the standard transformation in X3D. So maybe we don't need anything extra, and it turns out that we don't need, yeah, so the transform node is enough. We get this extra flexibility also that I mentioned, is that we can have multiple shapes with multiple coordinates that can be affected by one skin. In case of HANIM, to be clear, you also can have multiple shapes, but they need to share the same coordinate. No, yeah? So like to be precise. And I'm talking, but that's actually pretty much it. Yeah, I mean, there are also a lot of similarities, to be clear, between the skin node and the HIM specification. Like the skin node is a bit similar to the humanoid. Our fields of joints and skeletons are very similar. We have something in HANIM called joint binding positions, rotations, and so on. They are, I believe, a bit similar to inverse bind matrices in the glTF standard. So a bit of different way, but say the same thing. Yes. So not everything is different. Actually, as much as possible, I didn't want to make a revolution. Yeah. I just wanted to see, can I take the glTF approach and adapt it in a way in X3D that makes sense? And that was a lot of talking without. Did I even show something animated? I showed in Blender. Yeah, let's see something actually animated in Castle Game Engine at the end, and then I will basically give you time for talking. Give you time for questions. Sorry. Yeah? I think I was talking a lot, and I hope this was understandable. But before I give you time to answer questions, let me just show you some things, because so far I already showed this my ugly animation. I'm very sorry. Yeah? So this is not ugly animation. This was made by an actual artist. Yeah, and you can already see why I chose the name skin, and I wanted to also make it like more generic. Yeah, this is not for human. This is not a human. Yeah, so the skin animation is a technique of animation. It's not specific to humanoids. So that's, I also think, a little bit of an advantage in the name, that the skin node does suggest that this is a general technique, which it is. Yeah, it can be used for something weird like this, and it has some joints somewhere, and it's not a human at all. And by the way, we have also made a number of improvements to Castle Game Engine when we've been implementing it, and they also involve that you can make. No, sorry, I'm lost on another monitor, that you can also have. Yeah, so something doesn't work for me on this monitor. It should work now, because there is a fun way, actually, not a fun, sometimes useful way to visualize the animation joints. You can use this both with the H-anim visualize joints and with the skin joints, which are just transform nodes. So I can actually do this, yeah? And if I do this, you will actually see the names of the joints present in this model, yeah? It's a silly visualization. I know it's kind of hard to see here anything, but you can see some things. Yeah, you can see the positions of the joints, those balls that they are like where the joints transformation of the joints is pointing at. So the joints started there. And going forward, yeah, just some simple things implemented in Blender, made by Blender and exported to glTF by people who can actually do pretty things. Yeah, so thankfully you don't no longer have to watch my weird creations. This is actually a fox, so a standard model from Kronos. I opened it now in glTF version, but I can also open the same fox in the XVD version. And I mean, it works the same. That's of course the whole purpose of it. Let me also show you this fox, actually, the source code of this fox, yeah? So it looks like this, yeah? There's a node called skin. Inside there's a list of joints. Inside there's a hierarchy of skeletons, in this case using the def use mechanism of the XVD. And there's a list of shapes. The fox is composed from, I don't remember, but I have probably multiple shapes, many animations. Many animations use multiple shapes, obviously. Do I have here something? I have one thing, but that's on a project that is proprietary. I cannot show it right now. Yeah, Aaron, go ahead. Oh, yeah, I know what yeah. Aaron, I see that you raised the question. Do you want to ask a question now or just later?
Yeah,
Yes, please.
can you?
Michalis, let me say thank you. I have to skip out in a few minutes, but this was really tremendous. Could I offer a summary of our current related work, and
Yes,
then
but
discussion
then
could
let me
just go
finish.
on?
Can I finish just the? Is it okay if I first? I mean, now I
I
don't know what to
depart
do
in 8
first.
minutes.
Sorry?
I depart in 8 minutes, sir.
Because I took more time than I wanted. I'm
Please
sorry.
finish. Yes.
Okay, then I will finish. Okay, then Aaron, please hold on and let me just show very quickly one thing. Okay, I'm sorry, as I warned you, I'm getting very talkative sometimes. So let me just finish it quickly. So there's a bunch of more impressive animations. You can go ahead from download them from Sketchfab or from any other sites that have been designed in glTF and that we can play efficiently. So that's the short version of this demonstration. What I do want to show you right now, just for the ending, is what is actually being achieved by being able to make this skinned animation, by being able to perform it on the GPU. Okay, so just give it a second to build this demo. It's building because because I built it with a different version of the compiler before the meeting. So please give it like a few more seconds and it should run. And it should show something basically cool about why the animation, doing the animation on shader actually makes sense and allows us to achieve some nice things. And let it run. Go on, go on. Oh, there we are. Okay, so this is a very simple animation. It's actually designed in Blender in this case. And now this is a very simple animation actually performed by Pascal code. So it's moving the head, but you can imagine here that the game engine can do something more complex, like inverse kinematics. But this is not the core point of this presentation. The core point happens when I click here, add crowd. And the button add crowd, it's actually adding, I don't remember at this point how many. It's actually adding, I would have to look at this. But the point here is that it's adding a lot of instances. Oh God, 8 square multiplied by, so 8 times 8 times 3 times 3, yeah? So this is actually playing, this is showing as a crowd composed of this many characters, or some calculator, and how much is it? Yeah? Sorry, my computer is getting now slow from doing many things at once. Okay, so we displayed this many characters. And as you can see, the frames per second are still kind of reasonable, even if I look at them all, which is really a big crowd at this point. And the important thing is that they don't share the same animation. They can actually play completely different animation. Let me then make a short demo of this also. Okay. This one should compile much faster, and then I will let Don summarize and let everybody go. Again, sorry, like I cannot make a short talk, yeah? So this is actually a new version of this demonstration that will show that all of those characters, they actually play a bit of different animation, or some of them, they play a bit different time of the same animation, yeah? So some of those are clapping, some of those are running, and so on and so on. It's not 60 frames per second anymore, but it's still basically interactive, yeah? So it's still much better than not doing this on the GPU. Like in contrast, if I would try to do this amount of 500 animations, skinned animation, not on the GPU, but using the regular CPU to calculate the effect of the joints, it would do much worse. Now I'm activating shadows, which for now actually force the CPU rendering. And as you can see, I have now less than 1 frame per second, yeah? So it's no longer interactive, yeah? So this is the whole point of doing this using shaders, is that I can have so many characters and it's still very fast. And I took much more time than I intended. I'm very sorry about that. Don, go ahead, please, and do the conclusion now, and we can jump to questions. Thank you.
Yeah,
Thank you for
Michalis,
listening, by
thank
the way.
you
Thank you very much
so
for listening.
much. Big round of applause from everybody, I think. Very important. I don't want to stifle conversation. You guys can continue. I get to attend a joyful online meeting talking about X3D. So sorry I have to depart. But Joe and I did a lot of homework yesterday preparing an alternative example just so we could understand what you were saying. Let me briefly share this in the spirit of, boy, there's all sorts of excellent work that is emerging here thanks to your leaning forward efforts. We have a scene where we took a glTF model, Cesium Man, and we converted it. And this is now published online in our examples. And there's a partial implementation. You can see it almost mostly works. That's Excite. Better implementation is Castle Game Engine, of course, which did the conversion from glTF X3D. Michalis, you have some of our comments. What I'd like to point out to people who pay attention to the plumbing is that this is different from the way that H&M does it. We certainly have plenty of coordinate values, but oh jeepers, I had this queued up. It uses transforms to, it's so big, it's hard to navigate. It uses transforms to do translations and rotations and occasionally scaling. And H&M is simpler. It's different. It's more editable and authorable without requiring a tool. That doesn't make either one better or worse. It's just fitness for purpose. So what I think we're seeing here today is a strong candidate as a possible node, but we'd have to get clear. This is a great mapping of how glTF does business. But the issues you described, Michalis, all of them in your comparison with H&M, I got to say, they directly parallel all of the work many of the people on this call have been doing about how do we bring coveroid, how do we bring skin, how do we bring clothing and apparel, how might we do internal organs someday, what are the tiers? So I think your approach is actually a possible basis for an H&M skin node that might simplify a lot of other things we're all doing. So we might get the best of both worlds. That's my impression. My summary is, oh my goodness, what a great time to be alive. There's so much interesting progress. The more we do, the more we understand others, the more we see how exactly similar they are and a little different too. And so thank you for making us smarter. There are at least 100 questions backed up here. We might need another session. That's okay. The work will continue every week. So parting shot, thank you, Michalis, for once again leading the way into how could we make a repeatable, authorable, web-friendly future that's not just a publication of what fancy tools do, but something controllable by model authors.
Yep, Don, thanks. Thanks for working together yesterday on that example. Really helped understand what's going on in that in your operation. Very nice, Michalis. One thing I would say from the very top end of it is that in the Chronos and that Metaverse Standards Forum, right now they're trying to establish a glTF file for an avatar. And you won't be surprised at all to see that it's exactly what you're doing. So that's why I would suggest changing that from skin to avatar, or even from skin to coveroid, because from my very narrow view, it can't be called skin because it contains a skeleton. It's more than a skeleton. It's a character, and so. But thank you very much for this. It really helped me. And I see that exactly, there's a lot of questions underneath here on the content, but it really shows that for everything except transform has a center that really helps in this animation, specifying a humanoid and animating a human. It's giant steps ahead of what the glTF translation, rotation, scale is limited to, their node, which computes to our transform, but a lightweight transform without center. Okay, a lightweight transform without scale orientation. And so glTF right now is a very lightweight transform. Their node only has translation, rotation, and scale. So obviously for H&M, we need to be centered. So this is one reason why I would say that the rendition that you're doing it can't be in a humanoid container right now because it doesn't do joints. It does simple transforms. And so, but anyway, wonderful stuff. And thank you so much for stepping out on this.
Thank you, thank you. Just to address some things, yeah, I mean, I'm not saying that those joints that we're making, I mean, the transform nodes that I'm using, they have full XVD capabilities. So you could, in Castle Game Engine, in our transform nodes, of course, you can place a center node, but then it's a center node following the XVD specification of the transform.center, which means that it's relative to the parent transformation node. And I know that in case of H-anim joint, the center field is a little different, yeah. It's relative to the humanoid, yeah. So it's a different approach, yeah. And again, here I'm like very much not trying to say what is better. It's just different, yeah. When we take the model from glTF, then yeah, it doesn't have centers because the glTF doesn't even have a way to talk about centers,
Right.
yeah. So it doesn't need it, yeah. But if you talk about how it's implemented in Castle Game Engine, well, here we expose the full transform node. So you have the center, but the
Yes.
center following relative to the parent of the transform.
Yeah.
And then the second thing, just about the name, I did choose the name skin deliberately because this one corresponds to the concept of skin in glTF. So I know that the characters and avatars and humanoids, they are all like here within the scope, or at least the scope intersect, but maybe even one is within another, yeah. But I did want to keep
Nodes
the
and
name.
nodes and skin. Yeah. GLTF
Yes,
nodes and skin. Like
yes.
you
So
have it. The skeleton is separate and yeah.
yeah,
So,
so the thing is that I deliberately did not want to call it character, yeah, because like I want to be able to express here some weird things like this alien creature that I shown that was a bit like ugly, yeah. So this is also a skin, yeah, and from the perspective of a game engine, the difference between this weird alien creature and the humanoid, it doesn't matter, yeah, it's a skinned animation. Yeah? So in this sense, I did want to name it the skin, which I consider a more generic name. And I know that this is not something that I know that H-anim is more interested from the very name, yeah, in being more specific for humanoids, or at least for the humanoid-like creatures, yeah. And the avatars and I guess things like that, well, they are something a bit more specific, yeah. So I would say that like the glTF skin is like a very general animation technique, and it just doesn't even try to talk about some of the things like the standard names for the human joints, yeah. What is my hand called? What is this thing, yeah? The skin specification in glTF and the skin specification in Custom Game Engine, we don't even try to go there, yeah. You can name this thing however you want. And that's very different from the H-anim and also from, I guess, the avatars in metaverse, yeah? Because there, I do understand, of course, there you need to care about the naming of those things to be able to actually have some consistency and also possible animation transfer, yeah? In our case, it's like, each game, each application can choose to follow conventions or not. And maybe, maybe I'm making a game about aliens and they all look like a weird worms. Yeah. So maybe I invented different conventions for
well,
joints. So
I
that's
just think,
just the reason for the generics note. Yeah. Sorry, and I talk too
and
much again.
else
Thank you.
it's under the covers, it's the same stuff. X3D does joint list points. GLTF does points list of joints. So it's either X3D is points to joints and GLTF is joints to points. But it's the same data underneath. Oh, it's the same index and weight. That's
Yeah.
all. So it fits together real well, and it's great. And thank you.
Yeah. Thank you.
I
Thank
got
you.
more
And yes.
examples.
Yeah, so I got a question, Michalis. And can you? So the transform is the same as any scene graph node, right? So you could put non-skin shape nodes as children of the transform node.
Yes, exactly.
Yeah, so we could like add, like if they want to hold a gun or a sword or whatever, that would go there as a regular old mesh node, not part or regular old shape node, not part of the actual skin weighting.
Exactly.
And
Yes. Thank you. Thank you for mentioning. Yes, exactly. This is like, yeah, because this skeleton here, I only show here an example with transforms, yeah. But the idea here is that you can put here anything you want, any grouping node, also any shapes. If you put some shape here inside the skeleton, then it's just like in the X3D. You have a shape that is inside the transformation. If you move the transformation, you're moving the shape also. So that's where you would add a gun or a hat on your head, any rigid object that is not deformed by the joints, it just goes here. So yeah, yeah.
and in theory, then you could put, if we ever implement something along cloth physics, you could put a cloth physics object inside that
Yeah, if the
scene
cloth
graph.
is exactly. Yeah, if the cloth is not affected by the joints, at least not using the same algorithm, yeah, they just put the cloth here, and it's like yeah. Thank you. That was something I forgot to mention. Yes, thank you.
And so, yeah, Michalis is, I've been working with Michalis to get export out of Maya skid nodes, and I can show that Michalis if you would like.
Yes, I very much would like it. Yes, and also thank you, Aaron, by the way, for like essentially validating that this even makes sense, and basically reviewing a lot of the things that I've been showing. Yeah, so that's yeah. Let Aaron show. I will actually also mention over this one thing that I forgot to mention is that this work has actually started when I was implementing an import of a motion capture data for a company which wanted to remain anonymous, so I cannot tell what company it is. The animation format was MVMX, if I didn't butcher the name. And so we actually made it, yeah? So we can import motion capture data into a skeleton inside the skin node and animate it efficiently, yeah? And my future interest is also looking at importing the BVH motion capture data and see how it can work. And I know it's possible because there are already importers from BVH to glTF. So I kind of want to just do the same thing. So it's an easy path that somebody else already like did the hard work for me, and I know it's possible. Yeah. And I'm sorry, I'm talking now over Aaron. Go ahead. So thank you.
Yeah. So I've got this character. Everybody's probably seen the H&M version of this character. It's a I didn't do anything special to this. In fact, I had to do less to this model than to the other models that I export H&M of it. So essentially, I go to export. I select, either with 4 influence joints per vertex or 8. But I'll do with 4 this time and just save as X3D. I'll just re-export to this skin test 01. And this is where it fails live. Actually, it just takes a little bit to do the animation part of it. All right, so and I go in here. I go open the same file. Where is it? Where is it? Skin test A. And so there we go. It's just like the inside Maya. And if we could look it up, we could look at that. I'll stop that. Stop. And we can open up that file here just to see what it looks like. As soon as I remember where I put it.
No caller.
Of course there is. Why would it go to voicemail? Let's see, where is it? There it is. Boom. Open. Do that. It'll still take a second. You can see we have the inverse bind matrices here. You guys all can hear me, right?
Yes,
Yep.
yes,
And
I
then we
hear
have
good.
and then we have the transform nodes. I haven't implemented the tool in Maya, but I'm going to implement the tool in Maya that will take the joint labels in Maya and rename the actual transform nodes with those joint names. But right now I'm exporting the joint labels from Maya just as a metadata string as metadata on that transform node. But I'm going to put a tool in there because some people just don't want to use that, right, Michalis? I'm going to put a tool in there that if it has a joint label, it will just rename the node the joint label at export time. But yeah, we
Yeah,
go.
it seems like to me that Michalis could have named that joint. The only thing is that the center value isn't used. So uh, it, the joint is just a transform with some additional parts that are not used in this.
Yeah,
But
Michalis, you said at one point you were thinking about also making H-anim joints usable in place of transforms. You could do either or. I don't know if you're
right,
still contemplating that or not.
yeah. Well, I don't see why. And if you put a joint, then you have an opportunity to add a segment and sights to it. And the only difference
Well,
being
I mean,
that
yeah.
this one is animated by rotation of the translation, and the other is animated by rotation of the center. And so, and to me right now, what I've seen in the MSF is that there's really two lines of stuff of avatars, and one line is this line that uses the simple transform of that you've used there, or the simple joint that animates by translation or by rotation of the translation. And so all I'm trying to say is that it's the same but different. The transforms that you're using in here make it necessary for the avatar to be drawn in relative terms. The joints are relative to each other rather than absolute number, like we can do when we use a center. We can use absolute measurements from 0, 0, 0, where in here you have to use relative transformations to place those joints. And so so thanks. I'd like to show you if you have
Just
if we've got time, I'd like to show you that one Don and I went through yesterday. And I'd
yes.
like to ask a big question is what happens when you don't provide that inverse bind matrix?
By
I,
default, they are identity, and other than that, it makes sense.
I thank you.
Yeah. I just want to add one comment to what you said. Like, to be clear, both H-anim joint node and I mean the way they are used. I get what you're. Let me phrase in a different way what you also I think said, Joe. But just to be clear, yeah. So like both the transform node and the H-anim joint node, they all have transformation, rotation, scale, center, and the scale. And
Right.
in both of cases, you can animate them by moving any of those stuff. So just to be clear, like technically and from the specification point of view, you can animate just hanim joint dot translation if you want to. Yeah. Now the
Yes.
difference, and I believe I know Joe from the mailing list, so I know that he means what I think he means, is that the practical usage of it is a bit different. The important distinction here is that the center of the H-anim joint is not relative to the parent joint, but it's relative to the humanoid. And this makes a huge difference. I do believe that this is important thing that Joe here meant, yeah? But to be clear, like those fields are present in all of those, in both of those nodes. Okay, I think I said what I wanted. I'm sorry. I wanted to essentially like make it clear, yeah, that those fields are present
Good. I
both
think I
there
got
and
it.
there. The important distinction is whether they are relative to the humanoid or not. Yeah.
Yeah. Well, to me, the important point is how they're operated, because like in the H-anim spec, it says we don't translate we don't use translation in animating the figure. because the hierarchy, we can animate it totally using center rotations. We don't need to, as a matter of fact, the only reason you do a translation on a joint or a transform like you have there is you're trying to show how the segments can become disconnected. I mean, that's how you break the skeleton is you use translations. If you use, except for the root, okay, we say the root, we do translation rotation of the whole thing, or for each joint, we do a transform at 0, a translation at 0, and a center where we want the rotation to be in absolute terms from 0, 0, 0. So it's a little bit different. And I'm blabbing, but in the glTF and the MSF, to me, it's still sort of like there's this figure for games, and that's what you're providing here, because this is a standard kind of setup for game armatures. They're 0, 0, 0 is someplace, and all the joints are relative to each other in some stack, and the skin is connected by collecting the joints and saying the weights. And then in the what I'm trying to call, maybe I'm doing too much, but the practical H-anim is like it's described in the H-anim spec. It's practical because it has because you define the skeleton precisely in terms of absolute measurements, and you use a hierarchy to joint centers to provide the animation. I mean, so that's the kind of to me, the practical and more extensive design of a responsive humanoid. But anyway, they're just two levels. That's what I'm dividing up in my brain, because I don't want to adapt in terms of transportable animations. I don't think I can, it's more difficult for me to make a transportable animation from the H-anim spec into this. I can make transportable animations for other versions of these, and I'm also I'm also seeing that they're really not building custom avatars. The avatars that are being built are very similar to each other, and they're similar because they can use the same clothes, they can use the same bindings, and so forth. So, but I think what I want you to do with this, Michalis, is to turn this into a JSON file that can be a glTF file. And we need to get back and forth between the X3D that you generated and a glTF. And I know the export that I saw in your player yesterday works great. But anyway, I'll shut up.
If you need a JSON file like that, Rocky can export the skin node to the JSON format.
Yeah, because like I say, this is what they're calling a extension that's called an avatar, because it has the hierarchy, has the joints in it, it has a mesh, it has other pieces, and it has the joints to point bindings that are just the opposite kind of X3D H-anim, but they're the same data. It's the same data. And like somebody would say, okay, in the authoring tool, Blender, okay, it acts like the weights are on the joints, but it acts like the weights are on the bones. You sort of see the scaling that way, and the helpers that make you think that the weights are being assigned to the bones, but they're really the same data assigned to a joint. And anyway, I've gone too far probably, but I appreciate your work a lot. And yours too, Aaron. I want to capture that character and put him in the lineup.
Well, I don't own the IP rights to that character, so it's not something we can sort of post as something related to it's not something the Web3D can post indiscriminately. It's just a real easy character for me to test with.
Okay, good.
Sorry, Joe, you cut out there. We didn't hear you at the last comment.
Good. trying to get it, going to try to get that model in.
But it would be nice to get some more content that we can post. So I've got Arian working on some stuff, but she's got a problem getting the polygon count down. So once she has a polygon count down, or once she gets the polygon count below 60,000 polys, we'll start posting our content, and then you can use it.
15 to 20 is a good 15K to 20K is a good one for standard ones coming out of the apparel CAD. Just a heads
Yeah,
up.
her problem is that she's well over 1 million.
Yep.
we want to get into at least the five digit area.
Good, because I think it's a good test, because one of the things that I've seen is a lot of the X3D has very small number of vertices, and so I think it's good to be able to test for file sizes that range, and then that'll give you an idea of scope as well.
Yeah, the last version of hers that I exported out to X3D was so large I thought it locked up Maya, even though it didn't. And then when it was done, and the character was 250 megabytes in size. So
I want the test case. Give it to me. I want the test case. That's an excellent also thing. Okay, maybe it will load for a while, yeah. But like the GPU and shaders can handle mesh with million of vertices and can animate it, yeah. So I want this test case.
Yeah,
yes.
all right. We'll give you we'll give you a copy of that when I'm ready to sit and watch my computer sit for 5 minutes.
Well, isn't it pretty much common?
It would probably do it faster, but I gotta remove some of the print statements from the export.
Isn't it pretty much common that developers might work in higher resolution there, but when they go to put it in a game, they subdivide it and use a lot fewer vertices, but they can still use the mapping from the of the textures and so forth from the higher resolution model. I mean, I've heard that that's what really happens.
She just needs practice on how to do that.
Yeah, the 25,000 goes down to 5,000, but they use the same textures and effects on the textures that they were able to use at 25,000. That's kind of what I've seen and heard.
That's absolutely true. This process is called baking, and essentially we've been making the models for our games. That's a completely standard workflow at this point, yeah. So first you model a high poly version, maybe even in ZBrush or in any application, Blender or Maya or 3ds Max too, yeah. But you can make it you make it high poly. And then from this, you bake the textures. For example, you bake a normal map texture. So then later, you don't have a very complicated geometry. You just have a normal map texture that kind of represents, approximates the same complexity on a surface. And you get a model that is more low poly, but looks similar. And of course, over time, the definition of how much vertexes is high poly and how much vertexes is low poly, those things change as the capabilities of our hardware changes. Yeah. But the workflow still remains the same, in the sense the artists, they still, I guess, look at and work with those extremely high poly things, and then they make something simpler to actually render it efficiently everywhere.
Yeah.
Thank you, everybody, for good words. Thank you. I see in chat. Thank you.
Thank you, Michalis. I'd like to talk to you about presenting